Hi, welcome back to Buy Forever. So this is another mini video in the series of the Input magazine, found in issue 3. It's quite a nice machine code um, programming section again. I love the illustrations in these things. I don't know who the artist was, but it's just really cool actually. Proper poster art. So you see there. Anyway, this is like a advantages of machine code section, and it's essentially showing the speed of machine code versus basic. I know everyone's pretty much convinced about that, but this is quite a telling example actually. So I've typed in this code. This is on ZX Spectrum again. I'm running an emulator. I've got I think it's called ZXSP, and that's on the Mac. I've also pulled up the memory disassembler, so there's an option. The good thing about emulators is you get all this sort of thing for free, so you can debug your code. You can even view the CPU as it's running. It doesn't actually seem to slow it down on this MacBook Air. Um, and there's all your registers and everything. Of course, that's running anyway. We're not even running any code, but the operating, if you like, the operating system, the ROM code in the Spectrum's still doing things. It's refreshing the screen, um, and looking for keyboard input and stuff like that. So yeah, the line numbers are different in my code to what this got there, just because uh, I converted it from the next program actually. It was just quicker to do that than type it again. So again, you got this like tiny little this section here, the data statement. There's not many instructions in this machine code, but effectively it's doing what line 30 to 35 is doing, this for loop, and it's going to fill the screen with the value n minus or the peak in n minus 1634. And that is, I think that is the start of, when you look at where that started from, this is the start of ROM. I read all the memory, so it's the address 0. I've run this already, and you can actually see in the memory disassembler the machine code's been read into 30,000, which is 7530 in hex. And it's essentially, you can see it's doing this LDIR instruction, but it's setting it up first. Setting up HL with 0, which is essentially what the for loop does with the peak there, and then setting DE up with 4000 hex, which is that's the start screen memory, so that is 16384. BC sets it up to 6144 in decimal, which is actually the number of pixels on the screen. And what the LDIR instruction does, it loads DE with the value of HL and then decrements BC, and then that one instruction basically carries on doing that until BC equals 0. So it's just like one, you basically set this up and then one instruction, and you'll see in a minute, I'll just actually run this code. It's going to go through the basic version of it. But you see how slow that is, doing each line at a time. And the way it's doing it is, it's the screen memory on the ZX Spectrum is laid out in 3 separate blocks vertically. So that's what it's doing. And also the each 8 pixels down is in a separate. It's just the way it's organised in memory. You see, it's taking a while, and having this CPU window up is not slowing it down at all. But you'll see, once it eventually finishes that and moves on to the machine code version, you probably won't even see it happen. So it actually pauses as well between. You can see there's a little pause 100. So it pauses for a short time after it's printed now machine code. So wait for it, there you go. So any second now, bang, there you go. It's done it almost instantaneously. So yeah, if anyone needed any more proof or example that machine code is fairly fast, that's one of them. And especially this LDIR instruction, it's just super fast for copying, basically copying memory or setting memory. Yeah, so there you go. Well, thanks for watching. I'll probably do another few videos on this input magazine, just sort of looking through all different issues of it, finding some interesting things. Anyway, thanks for watching and bye for now.